Azure Resource Manager serves as the cornerstone of Azure's management capabilities. As we delve into this powerful service, it's essential to understand its fundamental role in the Azure ecosystem. At its core, Azure Resource Manager acts as a centralized deployment and management service. This robust tool empowers administrators and developers alike to efficiently handle resources within their Azure environment. By providing a unified management layer, it streamlines the process of creating, updating, and deleting resources in your Azure account. One of the key strengths of Azure Resource Manager lies in its ability to manage infrastructure effectively. Whether you're dealing with virtual machines, storage accounts, or networking components, this service offers a consistent approach to resource management. This consistency not only simplifies your workflow, but also enhances your ability to maintain and scale your Azure solutions. Furthermore, Azure Resource Manager plays a crucial role in application deployment and management. It provides the necessary tools and APIs to seamlessly deploy complex applications, ensuring that all components are properly configured and interconnected. This capability is particularly valuable in today's fast-paced development environments, where rapid and reliable deployments are essential. Lastly, but certainly not least, Azure Resource Manager incorporates robust security features through its role-based access control (RBAC) capabilities. This allows you to finely tune access permissions, ensuring that users and applications have the appropriate level of access to resources. By implementing RBAC through Azure Resource Manager, you can maintain a secure and compliant Azure environment, aligning with best practices in cloud security. One of the standout features of Azure Resource Manager is its provision of a consistent management layer across various tools and interfaces. This uniformity is a game changer for Azure administrators and developers, offering flexibility and efficiency in managing Azure resources. Let's start with Azure PowerShell, a powerful command line tool favored by many administrators. Through Azure Resource Manager, you can leverage PowerShell CMDlets to perform a wide range of management tasks. This approach is particularly useful for automation and scripting scenarios, allowing you to manage resources at scale with ease. For those who prefer a cross-platform command line experience, Azure CLI integrates seamlessly with Azure Resource Manager. This tool provides a straightforward way to create and manage Azure resources using simple, easy-to-learn commands. The consistency provided by Azure Resource Manager means that the concepts you learn in Azure CLI are transferable to other interfaces. The Azure portal, with its user-friendly graphical interface, also interacts with Azure Resource Manager behind the scenes. This means that whether you're using the portal for quick tasks or complex configurations, you're benefiting from the same robust management layer used by other tools. For developers and those building custom solutions, Azure Resource Manager exposes a comprehensive REST API. This API forms the foundation for programmatic interaction with Azure resources, enabling you to integrate Azure management capabilities directly into your applications. Lastly, client SDKs are available for various programming languages, all interacting with Azure Resource Manager. These SDKs abstract away much of the complexity of working with the REST API directly, providing a language-specific interface for managing Azure resources. Azure Resource Manager brings a multitude of benefits to the table, each contributing to more efficient, secure, and organized cloud resource management. Let's delve into these advantages and understand how they can elevate your Azure experience. First and foremost, group resource management stands out as a key benefit. Azure Resource Manager allows you to deploy, manage, and monitor resources as a group rather than handling them individually. This approach simplifies complex deployments and ensures that related resources are managed cohesively throughout their lifecycle. Consistency in deployments is another crucial advantage. With Azure Resource Manager, you can repeatedly deploy your solutions and have confidence that your resources are deployed in a consistent state. This repeatability is invaluable in maintaining environment parity across development, testing, and production stages. The use of declarative templates is a game changer in infrastructure management. Instead of relying on complex scripts, you can define your infrastructure using JSON templates. This declarative approach not only simplifies the deployment process, but also serves as living documentation of your environment. Dependency management is handled elegantly by Azure Resource Manager. It allows you to define the relationships between resources, ensuring they're deployed in the correct order. This feature is particularly useful in complex architectures, where certain resources depend on others to function properly. Integration of access control is a standout feature from a security perspective. Role-based access control, RBAC, is natively integrated into the management platform, allowing you to apply fine-grained access control to all services in your resource group. This integration simplifies security management and helps maintain the principle of least privilege. Resource tagging capabilities provide a powerful way to organize your Azure resources logically. You can apply tags to resources based on various criteria such as environment, project, or department. This organizational capability becomes increasingly valuable as your Azure footprint grows. Lastly, Azure Resource Manager contributes to better billing organization. By viewing costs for a group of resources sharing the same tag, you can clarify your organization's billing structure. This feature is particularly useful for cost allocation and budgeting in multi-team or multi-project environments. As we delve into Azure Resource Manager, it's crucial to familiarize ourselves with key terminology. These terms form the foundation of resource management in Azure and will be essential throughout your Azure journey. Let's start with the concept of a resource. In Azure, a resource is any manageable item that's available through the platform. This broad definition encompasses a wide range of elements, from virtual machines and storage accounts to databases and virtual networks. Essentially, if you can create, configure, or interact with it in Azure, it's likely a resource. Next, we have the resource group, a fundamental concept in Azure Resource Organization. Think of a resource group as a logical container that holds related resources for an Azure solution. The beauty of resource groups lies in their flexibility. You can group resources based on project, environment, department, or any other criteria that makes sense for your organization. This grouping simplifies management, allowing you to handle multiple resources as a single unit. Moving on, we have resource providers. These are the services that supply the resources you can deploy and manage through Resource Manager. Each resource provider offers specific operations for working with its resources. For instance, Microsoft.Compute provides virtual machine resources, while Microsoft Storage handles storage account resources. Understanding resource providers helps you navigate the vast array of services available in Azure. Templates play a crucial role in Azure Resource Manager. An Azure Resource Manager template is a JavaScript object notation JSON file that defines one or more resources to deploy to a resource group. These templates are powerful tools for consistent and repeatable deployments. They not only specify the resources to be deployed, but also define dependencies between these resources, ensuring proper deployment order. Lastly, let's discuss declarative syntax. This term refers to a way of expressing what you want to create without detailing the step-by-step process to create it. Azure Resource Manager templates use declarative syntax. You define the desired state of your infrastructure, and Azure handles the implementation details. This approach simplifies complex deployments and reduces the chance of errors that can occur with imperative, step-by-step scripts. Azure resource providers play a crucial role in the Azure ecosystem, serving as the backbone for resource deployment and management. Understanding these providers is essential for effectively working with Azure resources and optimizing your cloud infrastructure. At its core, a resource provider is a service that supplies a set of resources and operations for working with a specific Azure service. Each provider is tailored to offer functionality related to a particular aspect of Azure's capabilities. For instance, the Microsoft Key Vault resource provider specializes in operations related to storing and managing cryptographic keys and secrets. When working with Azure resources, you'll often encounter resource types. These are specified in a format that clearly indicates both the provider and the specific resource. Resource provider, resource type. This naming convention helps in clearly identifying and managing resources across your Azure environment. For example, Microsoft Key Vault Vaults refers to the Key Vault resource type offered by the Microsoft Key Vault provider. Before diving into resource deployment, it's crucial to familiarize yourself with the available resource providers. This knowledge serves several important purposes. Resource definition. Understanding resource providers helps you accurately define the resources you want to deploy to Azure. Each provider offers specific resource types, and knowing these allows you to correctly specify your infrastructure requirements. Location awareness. Different resource types may be available in different Azure regions. By understanding the providers and their resources, you can ensure that you're deploying to supported locations, avoiding potential deployment failures. API version management. Each resource type is associated with specific API versions. These versions can introduce new features or changes in functionality. Being aware of the available API versions for each resource type allows you to leverage the latest features while maintaining compatibility with your existing infrastructure. Optimization. Knowing the capabilities of different resource providers can help you optimize your Azure solutions. You might discover more efficient ways to structure your resources or leverage specialized features offered by certain providers. Troubleshooting. When issues arise during deployment or management of resources, understanding the underlying resource providers can be invaluable in diagnosing and resolving problems. Understanding how to create and utilize resource groups effectively is crucial for optimizing your Azure deployments and maintaining a well-structured cloud environment. At its core, a resource group is a logical container that holds related resources for an Azure solution. This concept of grouping is powerful, allowing you to manage multiple resources as a single unit. However, there are several important considerations and rules to keep in mind when working with resource groups. Firstly, resources within a group should share the same lifecycle. This means you typically deploy, update, and delete these resources together. If you have resources that operate on different schedules or life cycles, it's generally better to place them in separate resource groups. This approach simplifies management and reduces the risk of unintended consequences when making changes. It's important to note that a resource can only exist in one resource group at a time. This one-to-one relationship between a resource and its group helps maintain clarity in your Azure environment. However, Azure does provide flexibility in resource management. You can add or remove resources from a group at any time, and you can even move a resource from one group to another, although some limitations apply to resource movement. One of the powerful features of resource groups is their ability to contain resources from different regions. This cross-region capability allows you to logically organize resources that may need to be geographically distributed for performance or compliance reasons, while still managing them as a single unit. Resource groups also play a crucial role in access control. By using resource groups to scope access control for administrative actions, you can efficiently manage permissions across multiple resources. This approach allows you to add, remove, or modify resources easily without having to recreate assignments and scopes each time. When creating a resource group, you're required to specify a location. This location is where the metadata about the resources will be stored. It's not necessarily the location where your resources will be deployed, as resources within the group can reside in different regions. The choice of location for a resource group can be important for compliance reasons, as you may need to ensure that your metadata is stored in a particular region. It's worth noting that while resources in different groups can interact with each other, this interaction should be carefully considered. It's common for related resources that don't share the same life cycle to be in different groups. For example, you might have web apps in one group connecting to a database in another group. In practice, creating resource groups in Azure is a straightforward process, but the real skill lies in designing your group structure to best serve your organizational needs. Consider factors such as application architecture, billing requirements, security needs, etc. Azure Resource Manager locks serve as a crucial safeguard in your Azure environment, providing an additional layer of protection against accidental or unintended modifications to your critical resources. In the fast-paced world of cloud management, where resources can be created, modified, or deleted with just a few clicks, these locks act as a safety net, preventing potential disasters caused by human error or misconfiguration. The primary purpose of Resource Manager locks is to prevent the accidental deletion of resources. However, their functionality extends beyond this, offering different levels of protection based on your specific needs. Let's delve deeper into the key aspects of these locks. Scope of application. Resource Manager locks can be applied at various levels within your Azure hierarchy. You can associate a lock with a subscription, a resource group, or an individual resource. This flexibility allows you to implement a granular protection strategy, securing your most critical assets while maintaining flexibility where needed. Inheritance. One of the powerful features of these locks is their inheritance model. When you apply a lock at a higher level, such as a resource group, all the resources within that group automatically inherit the lock. This cascading effect ensures comprehensive protection and simplifies the management of security policies across your Azure environment. Types of locks. Azure offers two types of Resource Manager locks, each serving a distinct purpose. A. Read-only locks. These locks prevent any modifications to the resource. While users can still read and access the resource, they cannot make any changes to its configuration or delete it. This type of lock is useful when you want to allow viewing but restrict any alterations. B. Delete locks. As the name suggests, these locks specifically prevent the deletion of a resource. Users can still read and modify the resource, but they cannot delete it. This is particularly useful for protecting critical resources that should never be removed accidentally. Access control. It's important to note that the ability to create or delete management locks is restricted to specific Azure roles. Only users with the owner or user access administrator roles have the necessary permissions to manage these locks. This restriction ensures that the lock management itself is tightly controlled, preventing unauthorized removal or modification of these crucial safeguards. Best practices. When implementing Resource Manager locks, consider the following best practices. Apply locks to your most critical resources or resource groups. Use read-only locks for resources that should never be modified without explicit approval. Implement a process for temporarily removing locks when legitimate changes are needed. Regularly audit your lock strategy to ensure it aligns with your current security and operational needs. Considerations. While locks provide excellent protection, they can also impact legitimate operations if not managed properly. It's crucial to have a clear process for managing locks, including procedures for temporarily lifting locks when necessary changes need to be made. The need to reorganize resources is a common occurrence. Azure provides flexible options for moving resources between resource groups and subscriptions, allowing you to adapt your cloud environment to changing organizational needs, optimize costs, or improve management efficiency. The process of reorganizing Azure resources primarily involves moving them either to a new subscription or to a new resource group within the same subscription. This capability is crucial for maintaining an organized and efficient Azure environment as your cloud infrastructure evolves. When you initiate a move operation, Azure implements several safeguards to ensure the integrity of your resources. Resource group locking. Both the source and target resource groups are locked during the move operation. This lock prevents any write or delete operations on these groups until the move is complete. It's a critical safety measure to maintain data consistency and prevent conflicts during the transfer. Resource accessibility. Despite the locks on the resource groups, it's important to note that the resources themselves remain accessible. For instance, if you're moving a virtual machine, applications can still access and use that VM during the move process. This ensures that your operations can continue uninterrupted even as you reorganize your resources. Before embarking on any resource move, it's crucial to consult the Move Operation Support for Resources documentation. This comprehensive guide outlines which resources can be moved between resource groups, subscriptions, and regions. Not all resources support all types of moves, and understanding these limitations is essential for planning your reorganization effectively. The actual implementation of a move is straightforward. Select the resource group containing the resources you want to move. Click the Move button. Select the specific resources you wish to move. Choose the destination resource group. Acknowledge that you need to update any scripts or tools that reference these resources to reflect their new location. While the process seems simple, there are important considerations to keep in mind. Dependent resources. Some resources must be moved together with their dependencies. For example, when moving a virtual network, you must also move its dependent resources like gateways. Understanding these dependencies is crucial to avoid broken configurations. Service-specific restrictions. Different Azure services may have unique restrictions or requirements for moves. Always check the service-specific documentation for any special considerations. Impact on operations. While resources remain accessible during a move, it's still advisable to plan moves during low traffic periods to minimize any potential impact on your operations. Update references. After a move, ensure that all scripts, tools, and documentation referencing the moved resources are updated to reflect their new location. RBAC and policies. Moving resources may affect role-based access control, RBAC assignments, and Azure policies. Review and update these as necessary after the move. Monitoring and alerts. Update any monitoring tools or alert configurations that may be tied to the specific resource group or subscription of the moved resources. Managing the life cycle of resources in Azure is a critical aspect of cloud administration. This includes not only creating and maintaining resources, but also removing them when they're no longer needed. The process of removing resources and resource groups in Azure is straightforward, but it requires careful consideration to avoid unintended consequences. Resource groups in Azure serve as containers for related resources. When you delete a resource group, all the resources contained within it are also deleted. This feature can be both powerful and potentially dangerous, so it's crucial to approach resource group deletion with caution. Key considerations. Dependencies. Before deleting a resource group, it's essential to consider potential dependencies. Resources in the group you're deleting might be crucial for resources in other groups. Azure doesn't automatically check for these cross-group dependencies, so it's the administrator's responsibility to ensure that deletion won't disrupt other services. Comprehensive deletion. Deleting a resource group is an all-or-nothing operation. All resources within the group will be removed, regardless of their type or importance. This can be efficient for cleaning up entire projects or environments, but requires absolute certainty that all contained resources are no longer needed. Irreversibility. Resource group deletion is generally irreversible. Once confirmed, the deletion process begins, and recovering the resources can be challenging or impossible, depending on the resource types. Removing resource groups using PowerShell. Azure PowerShell provides a straightforward way to remove resource groups. The command is copy remove as resource group. Name resource group name. For example, to remove a resource group named Contoso RG-1, you would use copy remove as resource group, name Contoso RG-01. This command prompts for confirmation before proceeding with the deletion. It's a safeguard to prevent accidental deletions, but it also means you need to be prepared to respond to the prompt in automated scripts. Removing individual resources while deleting entire resource groups is common. Sometimes you need more granular control. Azure allows you to delete individual resources within a group. This can be done through the Azure Portal, Azure CLI, Azure PowerShell, or REST API, depending on your preference and use case. For example, you might want to remove a specific virtual network from a resource group. This operation removes the resource without affecting others in the same group. Alternatives to deletion. In some cases, rather than deleting a resource, you might want to move it to a different resource group. This can be useful for reorganizing your Azure resources without losing any data or configurations. The move operation keeps the resource intact, but changes its management context. Best practices. Use Azure policy to prevent accidental deletion of critical resources. Implement proper naming conventions and tagging to easily identify resources and their purposes. Regularly review and clean up unused resources to maintain a lean and cost-effective Azure environment. Use Azure Resource Graph to query and analyze your resources across subscriptions before making deletion decisions. Consider using Azure Advisor recommendations to identify unused or underutilized resources that might be candidates for deletion. Understanding and managing resource limits is a crucial aspect of effective Azure administration. Azure provides tools and information to help you monitor your resource usage against established limits, enabling you to optimize your cloud infrastructure and plan for future growth. Resource limits. Overview. Azure imposes limits on resources for various reasons, including platform stability, service level agreements, SLAs, and cost management. These limits apply at the subscription level and vary depending on the type of resource and the subscription tier. Viewing resource usage. Azure offers multiple ways to view your current resource usage against the established limits. Azure Portal. Navigate to the Subscriptions blade, select your subscription, and then click on Usage plus Quotas. This provides a comprehensive view of your resource usage and limits. Azure CLI. Use commands like AZ-VM list usage to get usage information for specific resource types. Azure PowerShell. Samdlets such as getAzVM usage can provide detailed usage information. Azure Resource Graph. This tool allows for more complex queries across multiple subscriptions. Benefits of monitoring limits. Current usage tracking. Regularly checking your resource usage against limits helps you understand your current consumption patterns. Future planning. By analyzing trends in your resource usage, you can better plan for future needs and avoid hitting limits unexpectedly. Cost optimization. Understanding your usage can help identify opportunities for cost savings, such as decommissioning unused resources or optimizing resource allocation. Increasing limits. For many resources, Azure provides a request increase link when you're approaching or have reached a limit. This feature allows you to request an increase in your limit subject to approval. The process typically involves selecting the subscription and resource type for which you need an increase, specifying the new limit you're requesting, providing a business justification for the increase. It's important to note that while many limits can be increased, all resources have a maximum limit as defined in the Azure documentation. These maximum limits cannot be exceeded, regardless of your justification. Best practices. Regular monitoring. Set up a routine to regularly check your resource usage against limits. Proactive planning. Don't wait until you hit a limit to request an increase. Plan ahead based on projected growth. Resource optimization. Before requesting a limit increase, ensure you're efficiently using your current resources. Documentation. Keep track of your limit increase requests and approvals for future reference. Automated alerts. Set up Azure Monitor alerts to notify you when you're approaching resource limits. Time for knowledge check. Let's go through each question and discuss the correct answers along with explanations. A new project has several resources that need to be administered together. Which of the following strategies would provide a good solution? Correct answer: B. Azure Resource Groups. Explanation: Azure Resource Groups are designed specifically for this purpose. They allow you to group related resources that share the same life cycle, permissions, and policies. This makes it easier to manage, deploy, and monitor these resources as a single unit. While Azure templates are useful for deploying resources and subscriptions are used for billing and access management, resource groups are the most appropriate tool for administering related resources together. Which of the following situations would be a good example of when to use a resource lock? Correct answer: A. An express route circuit with connectivity back to the on-premises network. Explanation: Resource locks are best used for critical resources that should not be accidentally modified or deleted. An express route circuit providing connectivity to on-premises networks is a perfect example of such a critical resource. Accidental deletion or modification could severely impact network connectivity. The other options, a non-production VM and a temporary storage account, are less critical and are often meant to be modified or deleted as part of regular operations, making them poor candidates for resource locks. Which of the following is true about resource groups? Correct answer: A. Resources can be in only one resource group. Explanation: This statement is correct. In Azure, a resource can only belong to one resource group at a time. This is a fundamental principle of Azure's resource management model. The other statements are incorrect. Role-based access control, RBAC, can indeed be applied to resource groups. In fact, this is a common and recommended practice for managing permissions. Resource groups cannot be nested. They exist at a single level in the hierarchy. Subscription resource group resources. Welcome to our discussion on Azure Advisor, a powerful tool in the Microsoft Azure ecosystem. Azure Advisor serves as your personal cloud consultant, designed to help you optimize your Azure resources and get the most out of your cloud investment. At its core, Azure Advisor is all about improvement. It continuously analyzes your Azure resource configuration and usage telemetry, providing personalized and actionable recommendations. These insights are invaluable for enhancing various aspects of your Azure environment. Let's break down the key areas where Azure Advisor can make a significant impact. First, it helps you optimize your Azure resources. This means ensuring you're using the right services for your needs and that those services are configured efficiently. Second, Azure Advisor is crucial for improving the reliability, security, and performance of your applications and services. It identifies potential vulnerabilities, suggests best practices, and recommends ways to enhance your system's stability and speed. Third, it guides you towards achieving operational excellence. This involves streamlining your processes, improving manageability, and implementing deployment best practices. Lastly, but certainly not least, Azure Advisor helps you reduce your overall Azure costs. It identifies unused or underutilized resources and suggests ways to optimize your spending without compromising on performance or capabilities. What sets Azure Advisor apart is its ability to provide recommendations tailored to your specific Azure usage and configurations. It's like having a cloud expert constantly monitoring your environment and offering advice, helping you make informed decisions about your Azure resources. Azure Advisor's power lies in its comprehensive approach to cloud optimization. To achieve this, it provides recommendations across 5 critical categories, each addressing a crucial aspect of your Azure environment. Let's explore these categories. First, we have reliability. In this category, Azure Advisor focuses on ensuring and improving the continuity of your business-critical applications. It provides recommendations to help you maintain high availability, recover from failures, and ensure your services are resilient to disruptions. Next is security. In today's digital landscape, protecting your resources is paramount. Azure Advisor helps detect threats and vulnerabilities that could lead to security breaches. It offers suggestions to enhance your security posture and safeguard your data and applications. The third category is performance. Here, Azure Advisor aims to improve the speed and responsiveness of your applications. It analyzes your resource usage patterns and suggests optimizations to enhance the overall performance of your Azure workloads. Operational excellence is the fourth category. This is all about achieving process and workflow efficiency. Azure Advisor provides recommendations to improve resource manageability, streamline your deployment practices, and enhance your overall operational processes. Last but certainly not least is cost optimization. Azure Advisor helps you optimize and reduce your overall Azure spending. It identifies underutilized resources, suggests right-sizing options, and provides insights on how to make the most cost-effective use of Azure services. Azure Monitor is a powerful and comprehensive platform that forms the backbone of monitoring and management in the Azure ecosystem. As we dive into this topic, you'll discover how Azure Monitor can transform the way you oversee and optimize your cloud resources. Azure Monitor is designed to be your central hub for all things monitoring in Azure. It's not just a simple monitoring tool. It's a robust platform that covers the entire spectrum of monitoring needs. Let's break down its core functionalities. First and foremost, Azure Monitor excels at collecting data on your resources. This isn't limited to just a few metrics or logs. Azure Monitor can gather a wide array of data points from various sources across your entire application stack. This comprehensive data collection forms the foundation for all other monitoring activities. Once the data is collected, Azure Monitor provides powerful tools for analyzing that data. This goes beyond simple data aggregation. Azure Monitor offers advanced analytics capabilities that can help you uncover insights, identify patterns, and detect anomalies in your resource usage and performance. Visualization is another key strength of Azure Monitor. It transforms raw data and complex analyses into easily digestible visual formats. These visualizations can range from simple charts and graphs to complex dashboards, making it easier for you to understand the state of your resources at a glance. But Azure Monitor doesn't stop at visualization. It also enables you to act on the results of your monitoring and analysis. This could involve setting up alerts to notify you of critical events, or even triggering automated responses to certain conditions. What sets Azure Monitor apart is its versatility. While it's deeply integrated with Azure services, its reach extends far beyond just Azure resources. You can use Azure Monitor to keep tabs on your on-premises resources, giving you a unified view of your hybrid cloud environment. Even more impressively, it supports multi-cloud scenarios, allowing you to monitor resources hosted with other cloud providers. This makes Azure Monitor an ideal choice for organizations with complex multi-cloud infrastructures. Azure Monitor's architecture is designed to provide a comprehensive and flexible monitoring solution. It's structured around three main components: data sources, data storage, and data usage and action. Let's explore each of these in detail to understand how Azure Monitor works. Starting with data sources, Azure Monitor can collect data from a wide range of sources. These sources span every layer of your application architecture, from the application itself down to the underlying infrastructure. This includes application data. This could be performance data or diagnostic logs from your code. Operating system data, both from Azure VMs and on-premises machines. Azure resource data, operational data about the Azure services you're using. Azure subscription data, information about the health and operation of your Azure subscription. Azure tenant data, data about the operation of tenant-level Azure services like Azure Active Directory. All this data is broadly categorized into two types: metrics and logs. Metrics are numerical values that describe some aspect of a system at a particular point in time, while logs contain event-based data. Moving on to data storage, Azure Monitor uses two fundamental types of data stores. Metrics database. This is optimized for time series datasets, which are especially useful for analyzing performance and trends over time. Logs database. This stores log data, which is great for complex querying and analyzing correlations. These centralized repositories ensure that all your monitoring data is in one place, making it easier to analyze and correlate events across your entire stack. Finally, we have data usage and action. This is where the collected and stored data is put to use. Azure Monitor provides several ways to leverage this data. Analysis and visualization. You can create dashboards, view live metrics streams, and use tools like Power BI for custom visualizations. Insights. Azure Monitor includes several insights, features that provide deeper analysis for specific types of resources. Alerting. You can set up rules to notify you when certain conditions are met, enabling proactive monitoring. Auto-scale. Based on metrics, you can automatically scale your resources to meet demand. Integration. The data can be sent to other tools and services for further processing or storage. This architecture allows Azure Monitor to provide a comprehensive view of your entire stack, from application to infrastructure, whether your resources are in Azure, on-premises, or in another cloud. It enables you to collect all the data you need, store it efficiently, and then use it in ways that provide real value to your operations. Azure Service Health is a crucial component in managing and monitoring your Azure environment. As businesses increasingly rely on cloud infrastructure, keeping track of the status and health of your Azure resources becomes paramount. This is where Azure Service Health comes into play. Azure Service Health is designed to provide you with a comprehensive view of your Azure environment. It combines three distinct Azure services to give you a complete picture, from the global Azure infrastructure down to your individual resources. Let's break down what Azure Service Health helps you monitor. First, it provides insights into the global Azure infrastructure status. This broad view allows you to understand if there are any widespread issues affecting Azure services across regions. Second, Azure Service Health gives you detailed information about your specifically deployed resources. This personalized view is crucial for understanding the health and status of the Azure services you're actively using. Lastly, it offers an overall status of Azure services. This view helps you understand the health of Azure services in general, which can be particularly useful for planning and troubleshooting. The key benefit of Azure Service Health is its ability to provide a comprehensive, multi-layered view of your Azure environment. It bridges the gap between global Azure status and the health of your individual resources, giving you a complete picture of your cloud infrastructure. By leveraging Azure Service Health, you can stay informed about any issues, planned maintenance, or changes that might affect your Azure resources. This proactive approach to monitoring can help you maintain the reliability and performance of your cloud-based applications and services. Azure Service Health is a powerful tool that combines three distinct Azure services to provide a comprehensive view of your Azure environment. Let's explore each of these components in detail. The first component is Azure Status. This service offers a broad picture of Azure's health on a global scale. When you visit the Azure Status page, you're presented with a global view of the health of all Azure services across all Azure regions. This is particularly useful for understanding widespread incidents that might be affecting multiple services or regions. If you're experiencing issues and want to quickly check if it's a global Azure problem, the Azure Status page is your first stop. The second component is Service Health. This provides a narrower, more focused view of Azure services and regions. Unlike Azure Status, which gives a global overview, Service Health is tailored to the specific Azure services and regions you're using. This personalized view makes it the ideal place to look for service-impacting communications about outages, planned maintenance activities, and other health advisories. One of the key features of Service Health is the ability to set up alerts. These alerts can notify you when service issues, planned maintenance, or other changes may affect the Azure services and regions you use. The third component is Resource Health. This offers the most granular view, focusing on your actual Azure resources. It provides information about the health of your individual cloud resources, such as a specific virtual machine instance. Resource Health is integrated with Azure Monitor, allowing you to configure alerts that notify you of availability changes to your cloud resources. This level of detail is crucial for pinpointing issues with specific resources in your Azure environment. By combining these three components, Azure Service Health provides a complete view of your Azure environment. It covers everything from the global status of Azure services and regions down to the health of your individual resources. This multi-layered approach ensures that you have all the information you need to manage and maintain your Azure infrastructure effectively. Moreover, Azure Service Health stores historical alerts, allowing you to review past incidents. This feature is particularly useful for identifying trends or investigating recurring issues. Something that initially seemed like a simple anomaly might reveal itself as a pattern when you review the historical data. In the event that a workload you're running is impacted by an event, Azure Service Health goes a step further by providing links to support. This integrated approach to problem-solving ensures that you have quick access to the help you need when issues arise. Azure Log Analytics is a powerful tool within the Azure Monitor ecosystem that serves as your primary interface for log data analysis. It's designed to help you derive insights from the vast amount of log data collected by Azure Monitor. At its core, Azure Log Analytics is where you write and run log queries. These queries allow you to sift through the data gathered by Azure Monitor, enabling you to find the specific information you need. Whether you're troubleshooting an issue, monitoring performance, or looking for security anomalies, log queries are your go-to tool. One of the strengths of Log Analytics is its flexibility. It supports both simple and complex queries, catering to a wide range of users and use cases. For beginners or quick checks, you can write straightforward queries to retrieve and filter data. As you become more comfortable with the query language and your analytical needs grow, you can leverage more advanced features to perform complex data analysis. Once you've run a query, Log Analytics provides robust features to work with the results. You can sort and filter the returned data, allowing you to quickly focus on the most relevant information. The tool also supports various analytical operations, enabling you to aggregate data, calculate statistics, and identify trends or patterns in your logs. Visualization is another key aspect of Log Analytics. You can easily transform your query results into charts or graphs, making it simpler to spot trends or anomalies that might not be apparent in raw data. These visualizations can be customized to suit your specific needs and can be invaluable for both analysis and reporting. While Log Analytics is powerful on its own, it's also designed to integrate seamlessly with other Azure Monitor features. For example, you can use Log Analytics to create and test queries that will be used in alert rules or workbooks. This integration allows you to leverage the full power of your log data across your entire monitoring and management workflow. What sets Azure Log Analytics apart is its ability to handle large volumes of diverse log data. Whether you're dealing with application logs, system logs, or custom logs from various sources, Log Analytics provides a unified interface to query and analyze all this data in one place. This centralized approach to log analysis can significantly streamline your troubleshooting and monitoring processes. Azure Monitor alerts are a crucial component of the Azure Monitor ecosystem, designed to keep you informed about important events or conditions in your Azure environment. These alerts serve as an automated early warning system, allowing you to stay on top of your resources' health and performance without constant manual monitoring. At its core, Azure Monitor alerts work by watching for specific conditions in your monitored data and triggering when these conditions are met. This could be when a metric crosses a threshold, when a certain event occurs in your logs, or when your resources' health status changes. The power of Azure Monitor alerts lies in their flexibility and customizability. One of the key features of Azure Monitor alerts is their ability to work with both metrics and logs. Metric alerts are typically used for numerical data that's collected at regular intervals, such as CPU usage, request count, or available disk space. These alerts can trigger nearly in real time, making them ideal for time-sensitive issues. Log alerts, on the other hand, are based on events recorded in your logs and can use more complex logic, allowing you to create alerts for specific error messages, unusual patterns, or custom conditions spanning multiple data sources. When an alert is triggered, Azure Monitor alerts can take a variety of actions. The most common is to send a notification, which could be an email, SMS, push notification to a mobile app, or even a voice call. But alerts aren't limited to just notifications. They can also trigger Azure functions, logic apps, or webhooks, allowing you to kick off automated remediation processes or integrate with other systems. A powerful concept in Azure Monitor alerts is the use of action groups. An action group is a collection of notification preferences and actions that can be associated with multiple alerts. This approach allows you to define a set of actions once and reuse them across different alerts, making it easier to manage and maintain your alerting strategy as it grows. Azure Monitor alerts also support a concept called smart groups. This feature uses machine learning to group related alerts together, reducing noise and alert fatigue. Instead of receiving multiple separate alerts for related issues, you get a single notification that gives you a more comprehensive view of the problem. Another important aspect of Azure Monitor alerts is their ability to be scoped to different levels of your Azure hierarchy. You can create alerts that apply to a single resource, a resource group, or even an entire subscription. This flexibility allows you to tailor your alerting strategy to your organizational structure and operational needs. Application Insights is a powerful feature of Azure Monitor specifically designed to monitor web applications. It provides developers and IT professionals with rich insights into the performance and usage of their applications, regardless of where these applications are hosted, be it in Azure, on-premises, or in another cloud environment. One of the key strengths of Application Insights is its comprehensive monitoring capabilities. Let's explore what it can monitor. First, Application Insights tracks request rates, response times, and failure rates. This gives you a clear picture of how your application is performing from a user's perspective. You can quickly identify if your application is responding slowly, or if there's an increase in failures that needs your attention. It also monitors dependency rates, response times, and failure rates. This is crucial for understanding how external services or databases are affecting your application's performance. If an external service is slowing down, you'll be able to pinpoint this quickly. For web applications, Application Insights provides insights into page views and load performance as reported by users' browsers. This client-side telemetry is invaluable for understanding the real user experience. AJAX calls from web pages are also tracked, including their rates, response times, and failure rates. This is particularly useful for single-page applications or apps with rich client-side functionality. Application Insights also keeps track of user and session counts. This helps you understand your application's usage patterns and user engagement. Lastly, it monitors performance counters from Windows or Linux server machines such as CPU, memory, and network usage. This server-side telemetry complements the application-level metrics to give you a full picture of your application's health and performance. What sets Application Insights apart is its flexibility in implementation. You can add it to your application in two ways: by installing an SDK in your application, or by using the Application Insights agent. The SDK method gives you more control and allows you to track custom events and metrics, while the agent method is simpler to set up and requires no code changes. Another powerful feature of Application Insights is its ability to send synthetic requests to your application. This allows you to monitor your application's availability and performance even during periods of low activity. You can set up tests that periodically access your application from various locations around the world, giving you insights into your global performance and availability. Application Insights integrates seamlessly with the rest of Azure Monitor, allowing you to correlate application-level insights with infrastructure metrics and logs. This holistic view is invaluable for troubleshooting complex issues and optimizing overall performance. Great! Let's take a moment to check our understanding of the concepts we've covered. I'm going to present two questions, and we'll discuss each one to reinforce our learning. Question 1. Which is not one of the recommendation categories for Azure Advisor? The options we have are reliability, capacity, and cost. Think back to our discussion about Azure Advisor. We talked about several categories of recommendations that Azure Advisor provides. The correct answer is capacity. While reliability and cost are indeed categories of Azure Advisor recommendations, capacity is not one of them. The actual categories are reliability, security, performance, cost, and operational excellence. This question highlights the importance of understanding the specific areas where Azure Advisor provides recommendations. Each of these categories focuses on different aspects of your Azure environment, helping you optimize various facets of your cloud resources and applications. Now, let's move on to the second question. Question 2. You receive an email notification that virtual machines, VMs, in an Azure region where you have VMs deployed is experiencing an outage. Which component of Azure Service Health will let you know if your application is impacted? The options are Azure Status, Service Health, and Resource Health. Think about the different scopes of these components within Azure Service Health. The correct answer is Resource Health. Let's break this down. Azure Status provides a global view of the health of Azure services across all regions. It would tell you about the general VM outage in the region. Service Health provides a personalized view of the health of Azure services and regions you're using, but it's still at a service level. Resource Health, however, provides information about the health of your individual cloud resources, such as a specific VM instance. In this scenario, Resource Health would give you the most precise information about whether your specific VMs, and consequently your application, are impacted by the outage. This question underscores the importance of understanding the different components of Azure Service Health and how they provide information at different levels of granularity. Remember, Azure provides these different levels of health monitoring to give you a comprehensive view of your environment, from broad service-level insights down to the status of individual resources. Azure CloudShell represents a significant leap forward in cloud management technology. This innovative tool provides a browser-based command line environment, offering unprecedented flexibility and convenience for Azure administrators and developers alike. At its core, Azure CloudShell serves as a versatile platform for managing a wide array of Azure resources. Whether you're dealing with virtual machines, storage solutions, or intricate networking configurations, CloudShell puts the power of command line tools at your fingertips, accessible from any web browser. One of the standout features of Azure CloudShell is its commitment to keeping you up to date. Microsoft takes on the responsibility of managing this environment, ensuring that you always have access to the latest versions of Azure CLI and PowerShell modules. This automatic updating eliminates the need for manual module maintenance, allowing you to focus on your core tasks rather than worrying about version compatibility. The simplicity of Azure CloudShell is truly remarkable. With just a web browser and your Azure account credentials, you can dive into a fully featured command line environment. This environment is seamlessly integrated with your account permissions, granting you immediate access to the resources you're authorized to manage. Security is a paramount concern in cloud computing, and Azure CloudShell doesn't disappoint in this regard. It operates within an infrastructure that provides double encryption at rest by default, offering an additional layer of protection for your sensitive data and operations. Another notable aspect of Azure CloudShell is its provision of persistent cloud storage. This feature allows you to store and access important files such as SSH keys and scripts across different sessions and machines. The built-in CloudShell editor further enhances this functionality, enabling you to modify your scripts and files directly within the CloudShell interface. In essence, Azure CloudShell combines the power of command line tools with the accessibility of a web browser, wrapped in a secure and always updated package. It's a testament to Microsoft's commitment to providing robust, user-friendly tools for cloud management. Azure CloudShell stands out as a versatile and powerful tool in the arsenal of IT administrators and developers. Its functionality shines through in real-world scenarios, such as the one faced by our IT admin at Contoso Corporation. Imagine you're on call during a family visit, and suddenly a critical issue arises with an Azure virtual machine. In the past, this situation might have necessitated a rushed trip back to the office or remote access to a specific workstation. However, with Azure CloudShell, all you need is a device with an internet browser. Accessing Azure CloudShell is straightforward and flexible. You can reach it through a direct link, https://judgeshell.azure.com, the Azure portal, or even from code snippets in Microsoft Learn. This accessibility ensures that you're never more than a few clicks away from powerful administrative tools. Upon initiating a CloudShell session, Azure allocates a temporary virtual machine to host your environment. This VM comes preloaded with the latest versions of both PowerShell and Bash, allowing you to choose the command line experience that best suits your needs and preferences. One of the key strengths of Azure CloudShell is its ability to mount an Azure file share. This feature provides persistent storage, allowing you to access your crucial scripts and tools across different sessions and devices. In our scenario, this meant the IT admin could quickly access and run diagnostic scripts to resolve the VM issue, all from a family member's laptop. It's important to note that CloudShell sessions are designed with both efficiency and security in mind. Sessions automatically terminate after 20 minutes of inactivity. While this means you'll need to start a new session if you step away for too long, it also ensures that idle sessions don't consume unnecessary resources. Importantly, any files stored on your cloud drive persist between sessions, so you don't lose your work or important scripts. The power of Azure CloudShell lies in its ability to bring robust Azure management capabilities to any internet-connected device. Whether you're in the office, working from home, or handling an emergency while on vacation, you have the tools you need at your fingertips. This flexibility and accessibility make Azure CloudShell an invaluable resource for IT professionals managing Azure resources. In our increasingly mobile and distributed work environments, Azure CloudShell offers robust capabilities for managing and accessing your scripts and files, enhancing your productivity and workflow efficiency. Let's delve into the key features that make file management in CloudShell both powerful and user-friendly. At the heart of CloudShell's file persistence is the Azure Cloud Drive. This feature allows you to upload files and access them across different CloudShell sessions, ensuring that your important scripts and data are always at your fingertips. Once you've uploaded a file to Cloud Drive, you can interact with it, just as you would in a regular PowerShell or Bash session. This persistence is particularly valuable when you need to switch devices or come back to a task after some time. For more extensive storage needs, CloudShell allows you to map an Azure storage file share. This feature is especially useful when you need to work with region-specific data or larger sets of files. By mapping a file share, you can access its contents directly through CloudShell, bridging the gap between cloud storage and your command line environment. When it comes to editing your scripts or files, CloudShell provides a built-in editor. You can access this editor by clicking the curly brackets nolls icon in the browser interface. Alternatively, if you prefer working from the command line, you can use the code command followed by the file name. For instance, typing code temp.txt would open or create a file named temp.txt in the editor. This integrated editing capability means you can make quick changes to your scripts without leaving the CloudShell environment. It's worth noting that the code command is available in the classic mode of CloudShell. To enable this mode, you can navigate to Settings and select Go to Classic Version from the More menu. One of the most powerful aspects of CloudShell is its pre-configured environment. It comes loaded with a wide array of tools and add-ons, saving you the time and effort of setting up your development environment. These tools span various categories, including Linux tools like Bash, ZSH, and Tmux. Azure-specific tools such as Azure CLI as Copy and Azure Functions CLI. Text editors including Vim, Nano, and Emacs. Source control with Git. Build tools like Make, Maven, and npm. Container management tools, including Docker Machine and kubectl. Database clients for MySQL, PostgreSQL, and SQL Server, and many more, including Terraform, Ansible, Chef, and even the Office 365 CLI. This extensive toolkit means that whether you're managing Azure resources, working with containers, or developing applications, you have the necessary tools at your disposal without any additional setup. In essence, Azure CloudShell's file management and tool integration capabilities transform it from a simple command line interface into a comprehensive development and administration environment. As an IT administrator for Contoso Corporation, you often find yourself needing to interact with Azure resources from the command line. Even when you're away from your primary administrative workstation, Azure CloudShell emerges as a powerful solution in such scenarios, offering flexibility and accessibility that traditional setups may lack. Let's explore when Azure CloudShell shines and when alternative approaches might be more suitable. Azure CloudShell proves invaluable in several key situations. Remote access. When you need to manage Azure resources but don't have access to your usual administrative device, CloudShell comes to the rescue. It provides a secure command line session accessible from any device with a web browser, ensuring you're always just a few clicks away from full Azure management capabilities. No local installation required. CloudShell eliminates the need to install Azure CLI, PowerShell modules, or other management tools on your local device. This feature is particularly useful when using a temporary or shared device, or when you need to quickly access Azure without going through a lengthy setup process. File persistence. CloudShell allows you to persist files between sessions. This means you can save scripts, configuration files, or other important documents and access them in future sessions. Regardless of the device you're using, this persistence enhances your productivity by ensuring your work is always available. Flexibility in command line environments. Whether you prefer Bash or PowerShell, CloudShell has you covered. You can choose the environment that best suits your needs, or switch between them as required, all within the same CloudShell interface. Built-in editor. The CloudShell editor enables you to modify scripts and other text files directly in the browser. This feature is invaluable for making quick adjustments to your scripts or configuration files without needing to switch to a separate text editor. However, it's equally important to recognize scenarios where Azure CloudShell might not be the best fit. Long-running scripts. CloudShell sessions automatically disconnect after 20 minutes of inactivity. This limitation makes it unsuitable for scripts or activities that need to run for extended periods without interaction. Administrative tasks. If you need elevated permissions, like sudo access, within the CLI or PowerShell environment, CloudShell won't suffice. It's designed to work within the constraints of your Azure permissions and doesn't provide additional system-level access. Custom environments. While CloudShell comes with many pre-installed tools, it doesn't allow for installation of custom tools or extensive customization of the environment. For tasks requiring specialized tools or configurations, a custom virtual machine or container might be more appropriate. Multi-region storage. CloudShell's storage is tied to a single region. If you need to work with data across multiple regions, let's have and go through the correct answers for the knowledge check questions and provide explanations for each. Which of these methods can you use to access Azure CloudShell from a computer running Windows 11? Correct answer. C. Use the Microsoft Edge browser to log into an Azure subscription. Explanation. Azure CloudShell is a browser-based shell experience that doesn't require any local installation. You can access it directly from any modern web browser, including Microsoft Edge, by logging into your Azure subscription. There's no need for Windows Subsystem for Linux or remote desktop protocol connections. You want to store a script that you constantly use for operations on Azure resources. This script needs to be rapidly available when you open a new Azure CloudShell session. Which of these procedures should you use? Correct answer. A. Upload the script to your cloud drive on an Azure CloudShell session. Explanation. Cloud Drive is a persistent storage solution provided by Azure CloudShell. When you upload a script to your cloud drive, it becomes readily available in all future CloudShell sessions, regardless of the device you're using to access CloudShell. This makes it the ideal solution for storing frequently used scripts. You have a script stored on the CloudShell storage. You constantly use this script for resource management, but you need to perform small changes to it. Which of these solutions is the best way to handle the situation? Correct answer. C. Use the CloudShell editor to make the necessary changes and save it directly on the cloud drive. Explanation. The CloudShell editor is a built-in feature that allows you to edit files directly within the CloudShell environment. This is the most efficient method for making small changes to scripts stored in your cloud drive. It eliminates the need for downloading and re-uploading the script or using external version control systems. Changes made using the CloudShell editor are saved directly to your cloud drive, ensuring the updated script is immediately available for use. These questions highlight key aspects of Azure CloudShell, its accessibility through any modern web browser, the persistence and convenience of Cloud Drive for storing frequently used scripts, the integrated editing capabilities that streamline the process of maintaining and updating your scripts. Bash, short for Born Again Shell, is a fundamental tool in the world of Linux system administration. As we begin our journey into Bash basics, it's crucial to understand its role and significance in the Linux ecosystem. At its core, Bash is a command language interpreter. It serves as an interface between the user and the operating system, allowing administrators to execute commands and control system functions with precision. What sets Bash apart is its versatility and power, combined with its adherence to Unix design principles. Bash became the standard shell for Linux systems due to its backwards compatibility with the original Bourne shell, SH, while incorporating advanced features. This compatibility ensures that scripts written for older Unix systems can still run on modern Linux distributions, providing continuity and stability for system administrators. One of Bash's strengths lies in its built-in commands, which offer a wide range of functionality without the need for external programs. These built-in commands are optimized for performance and provide essential tools for file manipulation, process management, and system configuration. Additionally, Bash excels at invoking external programs, seamlessly integrating various tools and utilities into a cohesive command line environment. This ability to combine built-in commands with external programs gives system administrators incredible flexibility in crafting powerful scripts and automating complex tasks. As we delve into Bash fundamentals, it's crucial to understand the basic syntax that forms the foundation of all Bash commands. The structure of a Bash command is elegantly simple yet incredibly powerful. Command options, arguments. Let's break this down. Command. This is the heart of Bash interaction. Commands are essentially programs or scripts that perform specific functions. For example, the ls command, short for list, is used to display the contents of a directory. It's often the first command new users learn, as it provides a window into the file system structure. Options, also known as flags. Options modify how a command behaves. They give you fine-grained control over command execution. Options typically start with a hyphen or double hyphen. For instance, the A option with ls tells the command to show all files, including hidden ones, those starting with a dot. Arguments. These specify the targets or parameters for the command. In the case of ls, an argument might be a specific directory path you want to list the contents of, like etc. A key feature of Bash that enhances its efficiency is the ability to combine options. Instead of writing separate flags, you can often string them together. For example, ls, a, l, etc. can be condensed to ls, al, etc. This command lists all files, a, in the etc. directory in long format, al, providing detailed information about each item. This combination of simplicity and power is what makes Bash so effective. With just a few keystrokes, you can perform complex operations on your system. As you become more familiar with Bash, you'll find yourself creating increasingly sophisticated commands, chaining them together, and even writing scripts to automate repetitive tasks. Remember, practice is key in mastering Bash. Don't hesitate to experiment with different commands and options in a safe environment. The more you use Bash, the more intuitive it becomes, and the more efficient you'll be in managing Linux systems. As you dive deeper into Bash, you'll encounter a wide array of commands, each with its own set of options and arguments. Remembering all of these can be challenging, even for experienced users. Fortunately, Bash provides built-in documentation to help you navigate this complexity. Let's explore the two primary methods for accessing this help: the man command and the help option. The man command, short for manual, is your comprehensive guide to Bash commands. When you run man followed by a command name, e.g. man mkdir, you're presented with a detailed manual page. These pages typically include a command synopsis, a description of the command's functionality, a list of all available options and their effects, examples of common usage, related commands, and additional resources. The man pages are exhaustive and can be intimidating at first, but they're an invaluable resource as you become more proficient with Bash. For a quicker overview, most Bash commands support the help option. When you append help to a command, e.g. mkdir help, you'll receive a concise summary of the command's syntax and its most commonly used options. This output is typically more digestible than the full man page and is perfect for quick reference or when you need a reminder of a specific option. Let's look at a practical example using the mkdir command. Man mkdir will open the full manual page, providing in-depth information about creating directories, including all possible options and their implications. mkdir help will display a brief summary of mkdir's usage, listing the most common options and their descriptions. This is ideal when you need a quick refresher on how to use the command. As you continue your Bash journey, make it a habit to explore these help resources. They're not just for beginners. Even experienced users regularly consult man pages and use the help option. These tools will help you discover new features understand complex options, and use bash commands more effectively. Wildcards in bash are powerful tools that allow you to work with multiple files or directories efficiently. They're especially useful when you need to perform operations on files that share certain naming patterns. Let's explore the most common wildcards and their applications. The asterisk. Case. The asterisk is the most versatile wildcard. It represents 0 or more characters in a file or directory name. For example, else PNG lists all PNG files in the current directory, does 2023, lists all files containing 2023 in their name. Orium. .tmp removes all files with the .tmp extension. The question mark, none. The question mark represents any single character. It's useful when you know the length of a file name but are unsure about a specific character. For instance, us. JPG lists all JPEG files with exactly 4 characters before the extension. MV file, txt, backup, moves all files named file1 ton txt, file2 ton txt, etc. to the backup directory. Square brackets. Square brackets allow you to specify a range or set of characters to match. This is particularly useful for more precise filtering, else, au. Lists files starting with any vowel. Else cache 9, txt lists text files ending with a digit ls. AMA lists files that don't start with letters A through M. Character ranges. Within square brackets, you can specify ranges of characters. SAZ lists files starting with any lowercase letter. SSAZ lists files starting with any uppercase letter. LSAZ09 lists files starting with any alphanumeric character. Combining wildcards. You can combine these wildcards for more complex patterns, as raw is a 9. AZ TXT lists text files containing at least one number and ending with a lowercase letter before the extension. Escaping wildcards. If you need to work with a file that actually contains a wildcard character in its name, you can escape it using a backslash. But special ton txt lists files with actual asterisks in their names. Remember, while wildcards are powerful, they should be used carefully, especially with destructive commands like rm. Always double-check your wildcard patterns before executing such commands to avoid unintended consequences. The ls command is one of the most frequently used commands in bash. It's essential for navigating and understanding the structure of your file system. Let's dive into its usage and some of its most common options. Basic usage. Simply typing ls in the terminal will list the contents of your current directory. This includes files and directories, but by default, it excludes hidden items, those starting with a dot. Example, copy else documents downloads, pictures videos listing, hidden files. To include hidden files and directories in the listing, use the A option. Else here, you'll see entries like current directory, parent directory, and hidden files like bashrc. Detailed listing. The L option provides a long format listing, giving you more information about each item. L this format shows file permissions, number of links owner name group, name file size in bytes. Last modification time file or directory name combining options. You can combine options for more specific listings. For example, LSL will give you a detailed listing that includes hidden files. LS all listing specific directories. You can specify a directory path as an argument to ls, bus, ya, etc. This will list the contents of the cha, etc. directory, regardless of your current location. Using wildcards with ls. Remember, you can combine ls with wildcards for powerful filtering. Else the max, this will list all files in the current directory with a text extension. The ls command is versatile and supports many more options. As you become more comfortable with bash, you'll discover how to tailor ls output to your specific needs, making file system navigation and management more efficient. The cat command, short for concatenate, is a versatile tool in Bash that is primarily used to display the contents of files. While its name suggests it can combine files, which it can, it's most commonly used for quick viewing of file contents. Let's explore its usage and some key points. Basic usage. The simplest use of cat is to display the contents of a single file. Our cat file name txt. This will output the entire contents of the file to the terminal. Viewing system information. One practical application of cat is to view system information stored in text files. For example, la cat, etc. OS release. This command displays information about the Linux distribution you're running, including its name, version, and other details. Multiple files. You can use cat with multiple files, and it will concatenate their contents in the order specified. Cat file 1.txt, file 2.txt. This will display the contents of file 1.txt followed immediately by the contents of file 2.1.txt. Creating files. Cat can also be used to create small files quickly. Use it with the output redirection operator. Cat new file.txt. This is a new file. I'm typing its contents directly. Press Ctrl+D to save and exit. Appending to files. To add content to the end of an existing file, use the append redirection operator. At cat existing file txt. This text will be added to the end of the file. Press Ctrl+D when finished. Displaying line numbers. Use the N option to display line numbers alongside the content. Cat and file name txt. Handling special characters. The V option displays non-printing characters, which can be useful for debugging. Count cat v file name txt. Caution with binary files. While a cat can display any file, it's best suited for text files. Trying to cat a binary file may produce unreadable output and can potentially mess up your terminal settings. The OH directory. As mentioned in the example, the OH directory is crucial for system configuration. Files here often contain important settings for various system components. When using cat or any command on files in Frekra, always double-check the file name to avoid accidental modifications. Be aware that some files may require root permissions to view. Never edit these files unless you're sure of the consequences. Remember, while cat is simple, it's incredibly useful for quick views of file contents, especially when combined with other commands in pipelines or scripts. As you become more proficient in Bash, you'll find numerous creative uses for this versatile command. The sudo command is a crucial tool in the Unix and Linux Administrators Toolkit. It allows users to execute commands with the security privileges of another user, most commonly the superuser or root. Let's delve into the details of sudo and its importance in system administration. Purpose of sudo. Sudo stands for superuserdo or substitute userdo. It provides a way to elevate privileges temporarily without logging in as the root user. This approach enhances security by limiting the use of the all-powerful root account. Basic usage. The syntax is straightforward. Copy sudo command to run. For example, sudo cat, etc. @ deny. This runs the cat command with root privileges, allowing you to view a file that might otherwise be inaccessible. Authentication. When you use sudo, you're typically prompted for your own password. This password is cached for a short time, usually 15 minutes by default. After the grace period, you'll need to enter your password again. Configuring sudo access. The file, etc. sudoers controls who can use sudo and what commands they can run. It's crucial to edit this file using the vsudo command, which checks for syntax errors. Viewing sudo privileges. You can see what sudo privileges you have by running sudo or running a shell with sudo. To start a root shell session, you can use sudo or sudo. Be extremely cautious when doing this, as all subsequent commands will run with root privileges. Security implications. Sudo logs all commands, providing an audit trail of administrative actions. It reduces the risk associated with having multiple users know the root password. However, it can be a security risk if not configured properly. Best practices. Use sudo only when necessary. Be very careful when using sudo with text editors or commands that can modify system files. Regularly review the sudo logs, usually in var log auth.log or var log secure. Limit sudo access to only those users who truly need it. Common use cases. Installing software. Sudo apt install package name. Editing system configuration files. Sudo nano, etc. config file. Restarting system services. Sudo systemctl restart service name. Remember, with great power comes great responsibility. The sudo command provides immense capabilities, but it should be used judiciously. Always double-check your commands when using sudo, as a small mistake could have significant consequences for system stability and security. Directory management is a fundamental skill in Bash. The commands cd, mkdir, and remdir are essential tools for navigating, creating, and removing directories. Let's explore each of these commands in detail. The cd command, change directory. Basic usage, cd directory name. This command changes your current working directory. Special notations.cd moves up one directory level cd car, or just cd changes to your home directory. ed switches to the previous directory you were in. Absolute versus relative paths. Absolute, cd, home, user, documents, relative. cd documents, if you're already in all home user. The mkdir command, make directory. Basic usage, mkdir directory. Name creates a new directory in the current location. Creating multiple directories. mkdir dir1, dir2, dir3. The parents or p option. Usage mkdir. Parents, parent, child, grandchild. Creates parent directories as needed. Useful for creating nested directory structures in one command, setting permissions while creating. mkdir. M755 new directory creates a directory with specific permissions. The rmdir command, remove directory. Basic usage. rmdir directory, name removes an empty directory, will fail if the directory is not empty. Can remove multiple empty directories. rmdir, dir1, dir2, dir3 using rm for non-empty directories. The rmdir command only works on empty directories. To remove non-empty directories, use rm with the r, recursive option. Usage, rm. R directory. Name. Be extremely cautious with this command, as it will delete the directory and all its contents without confirmation. Best practices and tips. Always double-check your current directory with pwd before using these commands. Use tab completion to avoid typos in directory names. When using rmr, consider using the I option for interactive deletion to prevent accidental removals. Remember that in Linux everything is case-sensitive, including directory names. Advancedusage.cd. P follows symbolic links to the physical directory. mkdir. V provides verbose output, telling you what's being created. Armdir P removes parent directories as well if they become empty. Common pitfalls. Trying to cd into a file instead of a directory. Attempting to create a directory that already exists. Use mkdir P to avoid errors. Forgetting that rmdir only works on empty directories. The rm command, short for remove, is one of the most powerful and potentially dangerous commands in Bash. It's used to delete files and directories, and it's important to use it with caution. Let's explore its usage and best practices. Basic usage. To delete a single file. rm file name. To delete multiple files, rm file 1, file 2, file 3. To delete all files in the current directory, rm. Use with extreme caution. Important options. Interactive. Prompts for confirmation before each deletion. Example, rm. filename r or r, recursive. Deletes directories and their contents. Example, r directory, name if, force. Ignores non-existent files and never prompts. Example, rmf, file name combining. Options.rem, ri directory. Name, recursively deletes a directory, prompting for each file. rmref directory par name, forcefully deletes a directory and all its contents without prompting. Use with extreme caution. Safety practices. Always double-check the command before pressing enter. Use the I option to prompt for confirmation, especially when using wildcards. Consider aliasing rm to rm, in your .bashik file for added safety. Be extremely careful when using rm with sudo. Common pitfalls. Using rm in the wrong directory can be catastrophic. The infamous rf command, never use this, can wipe out an entire system. Deleting files with spaces in their names without proper quoting alternatives to rm. Trashcli, a command line interface to the desktop trash can, creating an alias that moves files to a temporary directory instead of deleting them. Recovering deleted files. Once files are removed with rm, they are very difficult to recover. Some specialized tools exist, but prevention is the best strategy. Advanced usage. Verbose mode explains what is being done. VF removes a file actually named F. System safeguards. Many modern systems have safeguards against accidentally running rf. However, these safeguards are not foolproof and should not be relied upon. Ethical considerations. Be respectful when working on shared systems or with other people's data. Always ensure you have the right and permission to delete files. The cp command in bash is a versatile tool used for copying files and directories. It's essential for file management and backup tasks. Let's explore its usage and key features. Basic usage. Syntax. cp source destination. Example, cp file 1 .txt file 2 txt. This creates a copy of file 1 .txt named file 2 txt. Copying to directories. To copy a file to a directory, cp file txt path to directory. The file will retain its original name in the new location. Renaming while copying. You can rename the file during the copy operation. .cp original.txt newname.txt. Interactive mode. Use CPI to prompt before overwriting existing files. This is a safer option to prevent accidental overwrites. Example, cp file 1 .txt file 2 .txt. Recursive copying. R to copy directories and their contents. cp r source dir destination dir. If the destination directory doesn't exist, it will be created. Example, cp r photos backup photos. Preserving attributes. PKP. Use cpp to preserve the original file's mode, ownership, and timestamps. Useful for maintaining file metadata during backups. Copying multiple files. You can copy multiple files to a directory in one command. cp file 1 txt file 2 .txt file 3 txt destination directory. Using wildcards. Wildcards allow copying multiple files based on patterns. cp txt destination directory copies all txt files cp file. txt destination directory Copies file 1 txt, file 2 txt, etc. Verbose mode V. Use CPV to see a list of files as they are copied. Helpful for tracking progress in large copy operations. Combining options. You can combine multiple options: CP, REV, source, dir, destination, dir. This recursively copies, asks before overwriting, and shows progress. Symbolic links. By default, CP follows symbolic links. Use CPP to preserve symlinks without following them. Common pitfalls. Be cautious when using CP with wildcards to avoid unintended copies. Always check your destination to ensure you're not overwriting important files. Advanced usage, CP. Update or CPU. Copy only when the source is newer than the destination. CP, backup. Create backups of existing files when copying. The PS command, short for process status, is a crucial tool for monitoring and managing processes in Unix-like operating systems. It provides a snapshot of the current processes, offering valuable information for system administrators and users alike. Let's delve into the details of this command. Basic usage. PS without any options shows only the processes running in the current shell. This basic output is often limited and not very informative for system-wide analysis. Common options: PS, E or PS. A. Lists all processes on the system. PS. F. Provides a full format listing, including UID, PID, PPID, and more. PS. F combines E and F for a comprehensive full format list of all processes. PSOBSD style option that provides detailed information about all processes. Output explanation: UID, user ID of the process, owner PID, process, IDP PID, parent process ID. C. CPU utilization. STIME, start time of the process, TTY, terminal type associated with the process. Time, cumulative CPU. Time CMD, the command with all its arguments, useful variations. PSU username, show processes for a specific user PS. PPID, display information for a specific process ID. PS, sort tons PCPU. Sort processes by CPU usage, descending order, Ps, sort tons RSSS. Sort processes by memory usage, descending order, combining with other commands PS, EF. grep Firefox, find all processes related to Firefox. PSO, sort tatsia percent, mem, mers head in 10, list the top 10 memory-consuming processes. Historical note: the difference between PSEF and PS stems from historical Unix variants. PSEF is traditionally associated with System v Unix. PSOX is traditionally associated with BSD Unix. Modern systems often support both styles for compatibility, performance considerations. PS provides a static snapshot and is generally lightweight. For continuous monitoring, consider tools like TOP or HTOP. Security implications: regular users can only see their own processes in detail. Root or sudo access is required to see detailed information about all processes. Advanced usage: custom output format, PSEO, PID, PPID, CMD, %MEM, %CPU, sort, %CPU. This shows PID, PPID, command, memory usage, and CPU usage sorted by CPU usage. Integration with System Management PPS is often used in scripts for automated system monitoring and management. It can be combined with kill or kill-all for process termination. The W command in Bash is a powerful tool for system administrators, providing a quick snapshot of current system usage and user activity. Let's explore its features and applications in detail. Basic usage: simply type W in the terminal to see the output. No additional arguments are required for basic functionality. Output information. System uptime and load averages list of currently logged in users for each user. Username terminal, TTY remote host, if applicable. Login time idle time JCPU, time used by all processes attached to the TTY. PCPU, time used by the current process. Current process command interpretation of output. Uptime, how long the system has been running. Load average. System load over the last 1, 5, and 15 minutes. JCPU indicates overall resource usage by a user PCPU, helps identify resource-intensive processes. Common options. JOCU, H. Omits the header information. S. Uses short format, omitting login time, JCPU, and PCPU times. UF toggles between showing remote host name and IP address W user. Shows information only for a specific user. Security applications, identifying unusual login times or unexpected users, monitoring for potential unauthorized access. Tracking resource usage to detect abnormal activity. System administration uses. Checking system load and user activity before maintenance. Identifying users consuming excessive resources. Verifying successful logins after account setups or changes. Comparison with related commands. Who, similar, but provides less detailed information. Users, simply lists logged-in usernames. Last, shows history of logins and system reboots. Performance considerations. Yajao is lightweight and provides real-time information, useful for quick checks without significant system impact. Integration with other tools can be combined with grep for specific information filtering, often used in scripts for automated system monitoring. Best practices. Regularly check W output as part of system health monitoring. Use in conjunction with logs for a comprehensive view of system activity. Be aware of privacy considerations when monitoring user activity. Limitations. Provides only current snapshot, not historical data. May not show all types of connections, e.g., some remote desktop protocols. PowerShell has become an indispensable tool in the world of IT administration and automation. At its core, PowerShell combines two powerful components, a command line shell and a versatile scripting language. This unique combination offers IT professionals a robust platform for managing and automating various tasks across different systems. Initially developed as a framework for automating administrative tasks in Windows environments, PowerShell has undergone significant evolution. Today it stands as a cross-platform solution, extending its reach beyond Windows to encompass Linux and Mac OS systems. This expansion has broadened PowerShell's utility, making it a go-to tool for many kinds of tasks in diverse computing environments. The command line shell aspect of PowerShell provides a text-based interface for interacting with your computer system. While it may lack the graphical elements you're accustomed to in traditional user interfaces, this console-based approach offers several distinct advantages. For instance, working with a command line interface often proves faster and more efficient than navigating through graphical menus and options. This speed becomes particularly valuable when dealing with repetitive tasks or managing multiple systems simultaneously. Moreover, PowerShell's command line nature lends itself well to batch processing and automation. You can easily string together multiple commands to create complex workflows, making it an ideal choice for continuous integration pipelines and other automated processes. This capability significantly enhances productivity and reduces the likelihood of human error in repetitive tasks. Another key strength of PowerShell lies in its ability to interact with cloud resources and other remote systems. As more organizations adopt cloud-based solutions, the ability to manage and automate tasks across on-premises and cloud environments becomes increasingly crucial. PowerShell bridges this gap, providing a unified interface for managing diverse IT ecosystems. Perhaps one of the most significant benefits of PowerShell is its compatibility with source control systems. Commands and scripts can be stored as simple text files, allowing for version control, collaboration, and code review processes. This feature is particularly valuable in environments where traceability and auditability are paramount, such as government systems or highly regulated industries. With PowerShell, every change, update, or automation can be traced, evaluated, and audited, ensuring compliance with stringent regulatory requirements. PowerShell combines familiar elements of traditional command line shells with innovative features that set it apart in the world of IT automation and system management. Let's explore these features in detail. First, PowerShell incorporates a robust built-in help system. While most shells offer some form of help functionality, PowerShell takes it a step further. Not only can you learn about command syntax and parameters, but PowerShell's help system also integrates seamlessly with online resources. This integration ensures you have access to the most up-to-date information and examples, making it easier to learn and use PowerShell effectively. The pipeline is another feature that PowerShell shares with traditional shells, but with a significant twist. In PowerShell, the pipeline allows you to chain multiple commands together, where the output of one command becomes the input for the next. However, PowerShell's pipeline operates on objects rather than text. This object-oriented approach provides more flexibility and power in handling complex data structures and relationships. To ease the transition for users familiar with other command line interfaces, PowerShell supports aliases. These are alternate names for commands that allow you to use familiar syntax from other environments. For instance, you can use CLS to clear the screen or ALS to list files, just as you would in Unix-like systems. This feature helps new users leverage their existing knowledge while they become more comfortable with PowerShell-specific command names. One of PowerShell's most distinctive features is its object-based nature. Unlike traditional shells that work primarily with text, PowerShell operates on objects. This approach simplifies data manipulation and reduces the need for text parsing and formatting. You spend less time extracting the information you need and more time using it productively. PowerShell introduces the concept of CMDLETs, pronounced commandlets. These are the basic commands in PowerShell, built on a common runtime rather than existing as separate executables. This unified approach ensures consistent parameter parsing and pipeline behavior across different commands. CMDLETs typically accept object input and return objects as output, maintaining the object-oriented nature of PowerShell throughout your scripts and command chains. Lastly, PowerShell supports multiple types of commands. Beyond CMDLETs, you can use native executables, functions, scripts, and aliases. This diversity allows you to leverage existing tools and scripts while gradually transitioning to more PowerShell native approaches. It's worth noting that while the terms command and CMDLET are often used interchangeably, a CMDLET is specifically a type of command in PowerShell. PowerShell's cross-platform nature means it's available on various operating systems, but the installation process may differ depending on your specific environment. For Windows users, particularly those running Windows 8 or later versions, you're in luck. A version of PowerShell known as Windows PowerShell comes pre-installed on your system. While this version might differ slightly from the most recent PowerShell release, it's perfectly suitable for learning purposes. You can easily access Windows PowerShell through the Start menu, making it readily available for your exploration and practice. However, if you're using an operating system other than recent Windows versions such as Linux, Mac OS, or older Windows versions, you'll need to install PowerShell manually. The installation process varies depending on your specific operating system. To ensure you're following the correct procedure, it's recommended to consult the official documentation. You can find detailed, up-to-date installation instructions for various operating systems by searching for Install Various Versions of PowerShell in your preferred search engine. Regardless of your operating system, it's crucial to verify your PowerShell installation before proceeding further. This verification step ensures that PowerShell is correctly installed and functioning on your system. We'll cover how to perform this verification in the next unit of this module, so stay tuned for that important information. While PowerShell itself is a powerful tool, we can enhance our experience and productivity by using it in conjunction with an integrated development environment, IDE. For this purpose, we highly recommend using the PowerShell extension for Visual Studio Code. Visual Studio Code is a popular, free, and lightweight code editor that supports multiple programming languages and offers a wide range of useful features. The PowerShell extension for Visual Studio Code provides several benefits that can significantly improve your PowerShell scripting experience. It allows you to run PowerShell commands directly within the Visual Studio Code interface, providing a seamless integration between your code editor and the PowerShell environment. Additionally, the extension offers helpful features such as code snippets, which can speed up your script writing by providing templates for common PowerShell structures. Code completion is another valuable feature of the PowerShell extension. As you type, it suggests relevant CMDlets, parameters, and variables, helping you write accurate code more quickly and reducing the likelihood of syntax errors. The extension also provides syntax highlighting, which visually distinguishes different elements of your PowerShell code, making it easier to read and understand at a glance. By combining PowerShell with the Visual Studio Code extension, you create a powerful environment for authoring scripts, running commands, and managing your systems. As you embark on your PowerShell journey, one of the first challenges you'll encounter is navigating the vast array of available commands. PowerShell comes with thousands of CMDlets, which are compiled commands that can be invoked within the PowerShell environment. These CMDlets, developed in .NET or .NET Core, form the backbone of PowerShell's functionality. The key lies in discovering these CMDlets and understanding how to use them effectively. PowerShell CMDlets follow a consistent naming convention that can significantly aid in your learning process. Each CMDlet is named according to a verb-noun pattern. This naming standard serves multiple purposes. It helps you understand what a CMDlet does at a glance, makes searching for specific CMDlets more intuitive, and guides CMDlet developers in creating consistent, easily understandable names. To explore the approved verbs used in CMDlet naming, you can use the getVerb CMDlet. This command provides a list of all approved verbs, organized by activity type and function. For instance, you might see verbs like add, for adding a resource to a container, or clear for removing all resources from a container. This standardization helps maintain consistency across the PowerShell ecosystem. When it comes to locating and understanding CMDlets, PowerShell provides 3 core CMDlets that are invaluable in your exploration. Get command. This CMDlet is your starting point for discovering available CMDlets. When you run get command, it lists all the CMDlets installed on your system. This comprehensive list can be overwhelming, but get command allows you to filter the results, helping you quickly find the specific command you need. As you become more familiar with PowerShell, you'll find get command to be an essential tool in your toolkit. Get help. Once you've identified a CMDlet you want to use, the next step is understanding how to use it. This is where get help comes in. This built-in help system provides detailed information about CMDlets, including their parameters, usage examples, and more. You can also use the alias help to invoke get help with improved readability through pagination. This makes it easier to digest the wealth of information provided for each CMDlet. Get member. PowerShell operates on objects, and when you call a command, the response is typically an object with various properties. GetMember allows you to drill down into these objects and explore their properties and methods. This CMDlet is particularly useful when you're working with complex data structures or when you need to understand the full Capabilities of a CMDLET's output. As you work with these core CMDLETs, you'll find that they complement each other beautifully. You might start by using get command to find a relevant CMDLET, then use get help to understand how to use it, and finally apply get member to explore the output in detail. The get command CMDLET is an invaluable tool for discovering and locating commands. When you run get command in CloudShell, it returns a comprehensive list of every command installed in PowerShell. However, given the thousands of available commands, this list can be overwhelming. The key to effectively using get command lies in understanding how to filter its output to quickly find the specific commands you need. The verb-noun naming convention of PowerShell CMDLETs plays a crucial role in this filtering process. Recall that each CMDLET name consists of a verb that describes the action, like get or set, and a noun that describes the target of that action, like random or process. Get command leverages this naming convention to provide powerful filtering capabilities. To filter the get command output, you can use two primary flags, noun and verb. These flags allow you to target either the verb or the noun part of the command names you're searching for. Let's explore how to use these flags effectively. The noun flag. This flag targets the noun part of the command name. For example, if you're looking for commands related to aliases, you might use get command noun alias. The asterisk at the end of alias is a wildcard character. It tells PowerShell to find all commands whose noun part starts with alias. This search would return commands like getAlias, newAlias, and exportAlias. The verb flag. This flag targets the verb part of the command name. You can use it alone or in combination with the noun flag for more precise filtering. For instance, get command, verb get noun, alias. This command narrows the search to find commands that have get as the verb and a noun that starts with alias. This would return the getAlias command. The ability to use wildcards, me, with these flags adds flexibility to your searches. You can use wildcards at the beginning, middle, or end of your search terms. For example, get command. Noun process would find commands with process anywhere in the noun. Get command verb re would find all commands whose verbs start with re, like remove, rename, reset. As you become more comfortable with PowerShell, you'll find that mastering get command and its filtering capabilities significantly speeds up your workflow. Instead of scrolling through long lists of commands or trying to remember exact CMDLET names, you can quickly narrow down your search to find the exact command you need. Remember, the goal is to make your command discovery process as efficient as possible. Start with broad searches if you're unsure, and then narrow down your criteria as needed. Let's take a moment to reinforce our understanding of PowerShell commands and how to locate them effectively. This knowledge check focuses on two key aspects we've covered: locating commands and using get command with its filtering capabilities. Question 1. What's a correct way to locate a command in PowerShell? This question tests your understanding of the basic syntax for finding commands in PowerShell. The correct answer is A. Call get command, name of command. This syntax allows you to search for a specific command by its name. Remember, get command is the primary CMDLET used for discovering and locating commands in PowerShell. Options B and C using find or locate are incorrect. These are not valid PowerShell CMDLETs for finding commands. Always remember that PowerShell uses the verb-noun naming convention, and get is the standard verb for retrieving information. Question 2. How would you search for commands that deal with files? This question assesses your understanding of how to use get command with its filtering parameters, specifically the noun parameter. The correct answer is C. Call get command, noun file. Let's break this down. We use get command as our base CMDLET for finding commands. The noun parameter allows us to filter based on the noun part of the CMDLET name. File is used as the value for the noun parameter. The asterisk is a wildcard character that matches any number of characters. This means we're looking for all commands where the noun part starts with file. Option A is incorrect because it uses verb instead of noun. Remember, file is typically used as a noun in PowerShell CMDlets, not a verb. Option B is close but not quite correct. While it uses the correct noun parameter, it doesn't include the wildcard character, sol. Without the wildcard, this command would only find CMDlets with the exact noun file, potentially missing useful commands like getChildItem, which works with files and is often aliased as ls or dir. These questions highlight the importance of understanding how to use get command effectively. By mastering the CMDlet and its parameters, you can quickly and efficiently find the commands you need in PowerShell, significantly enhancing your productivity and effectiveness in using this powerful tool. Remember, practice is key in becoming proficient with PowerShell. Don't hesitate to experiment with different get command queries as you work on various tasks. This hands-on experience will help solidify your understanding and make you more comfortable with navigating the vast array of PowerShell CMDlets at your disposal.